right, then today we're going to be graphing quadratic functions, which are our parabolas. And we'll be able to find the minimum and maximum values. So we know that the graph of a quadratic function makes a parabola. You do want to look at the a value, and if the a value is greater than 0, meaning it's a positive number, then the parabola is going to open upward. If a is less than 0, meaning that it's a negative number of any kind, it will be a parabola that faces downward. So that'll give you kind of an idea of what the graph should look like. And then we are going to be finding the vertex and the axis of symmetry, and there's a formula for that. So the axis of symmetry is the line x equals negative b over 2a. That's also the coordinate of the vertex. So usually whenever we find the vertex, I'll write down the formula negative b divided by 2a comma blank. Now the reason I put a blank is that there's not a formula to find the y value. You have to find the x value first and then substitute it back into the original function and see what the output value would be for y. So the formula is to find the x coordinate of the vertex, and then you have to substitute that back in to find the y value. They also tell you that the y-intercept is always going to be 0, comma c. Okay, and you can see that the c is the constant at the end of the function without any. And these are in standard form. We're also going to look later at graphing them when they're in vertex form. Just like how we had linear, we had slope-intercept, point-slope in standard form. Quadratic, we will have vertex form in standard form. All right, so steps to graph the following functions. Find and graph the axis of symmetry, find and graph the vertex, and then you're going to find and graph the y-intercept and its reflection. Now, sometimes the y-intercept also is the vertex. When that happens, you're going to have to find another point on the graph and plot it. And just to be safe, you can always pick values for x and plug them in to get some points. Just doing a little table of values. All right, so remember, and actually sometimes I like to do these in a reverse order, based on how I have it here. Find the vertex first, and then find your axis of symmetry, but it's going to be using the same formula. So first of all, this is not in standard form right now because it is missing a middle term. You may want to rewrite it. So we would have 1/3 x squared plus 0x plus 1, just to remind yourself that that's a, b, and c. Just so you don't think that the 1 is a b. And then we'll use our formula for vertex, which is negative b divided by 2a, comma blank. And we'll substitute in b and a. So when it says negative b, it means the opposite of b. Well, the opposite of 0 is still 0. Zero divided by 2a, which would be 1/3. Well, 2 times 1/3 will get me 2/3. And 0 out of anything is still going to be 0, but just to show you, if you were not to have a 0 up top, you would want to change this division to be multiplication of the reciprocal, which would be 0 times the reciprocal 3/2, which is still going to get us 0. All right, so the vertex then is 0, comma something. So to find out what that something is, we're going to take the fact that x equals 0, and we're going to plug it back in for x to find out what the y value is. So 1/3 times 0 squared plus 1. So 0 squared is 0, 0 times 1/3 is 0, 0 plus 1 will get me 1. So the vertex happens to also be the y-intercept. Now if you remember when we did our absolute value function, usually we'll put the vertex in the middle of the table of values, that way we can pick a couple points above and below. Now since you do know that they will be symmetric, you can then just reflect it across the axis of symmetry instead of having to find so many points. Now the axis of symmetry, remember, is a vertical line, so it's always going to be in the form x equals, and it's whatever the x coordinate is, so it would be x equals 0. So let's go ahead and plot that, 0, 1. The axis of symmetry is x equals 0, which would be actually the y-axis. You can just use like a dashed or a dotted line there. Now, according to the directions, it tells us to graph the y-intercept, which we actually already have, and reflect it. So unfortunately this one we are going to have to pick another point. So you need to pick another x value to plug in. You can pick 1, you can pick 2, you can pick 3, you can pick 27, doesn't matter. Now when there's a fraction involved, I usually would pick things that would be divisible by 3. That way I know that my answer is not going to be a decimal or a fraction. So for example, I might pick 3, because 3 is divisible by 3. And then I'll evaluate by plugging 3 into my function, so kind of off to the side. 1/3 times 3 squared plus 1. So 3 squared is 9. 9 divided by 3 is 3. And 3 plus 1 will get me 4. So I'm going to plot that point. 1, 2, 3, 1, 2, 3, 4. And then remember, you can find P prime. Reflect that across the axis. So this is 3 spaces away. So I will go another 3 spaces on the other side. And I'll just tell you, if we were to pick another point like 6 or something, it's not going to fit on the graph. So we'll just sketch it as is. Normally we would pick like one more point and reflect it, but whenever we pick it and plug it in, it's going to be too far off, but it's going to be bigger than 10. Then they'll ask you a series of questions. Is this vertex, is this a maximum or a minimum? What do we think? Abby? Minimum. It's a minimum. It's the smallest value that it touches. So you just have to circle min. The domain of this function we know is always negative infinity to positive infinity because of the arrows of the 2 tips. And then this will review some of our range stuff from before. Who thinks they could tell me the range? Proper range. Using parentheses or brackets. Ashley?
Bracket 1, and parentheses.
Good. Then you're looking at the smallest y value it ever touches is 1, and it touches that 1, so that's a bracket. What's the largest value? Infinity. Excellent. All right, the next one, similar problem. We don't have fractions though, which is nice. So again, you might want to throw in the 0x just to remind yourself that that is hiding in there. So our A is 2, B is 0, C is -4. Find the vertex. They won't always be missing the bx term, it just happens to happen in the first two. So we're going to do our negative b over 2a formula. And we will get negative 0 over 2 times 2. So 0 divided by 4 is still 0. And then again, to find out what this blank is, we're going to plug 0 in for x. So 2 times 0 squared minus 4. Follow order of operations. 0 squared is 0. 2 times 0 is 0. 0 minus 4 is a negative 4. So my vertex would be 0, negative 4. Your axis of symmetry, again, is x equals whatever the x-coordinate of the vertex is. So it has to go through there. So this will be x equals 0, just like it was in the last one. The axis of symmetry is actually the y-axis. Again, the problem falls into place that we would normally pick the y-intercept and then reflect it, but the y-intercept is the vertex. Now, since there's no fractions, you can pick any number to plug in, which up here you could have picked 1. You'll just end up getting like a repeating decimal and have to estimate it. But I would just pick maybe like 1 and 2. And we'll plug those in. And we could just do this mentally. 1 squared is 1. 1 times 2 is 2. 2 minus 4 is negative 2. You don't have to show the work for it. 2 squared is 4. 4 times 2 is 8. 8 minus 4 is 4. Okay, so let's plot those points, and then we'll just reflect them across the axis of symmetry. So 1, negative 2, and 2, 4. So we'll just take and we'll reflect those across the axis of symmetry. Again, just counting how many spaces away. So it's 1 space away, so you go another 1 space. This one is 2 spaces away, so we go another 2 spaces. And then we'll connect those with a parabola shape. Again, you want to make sure that it does appear to be curved, not little connect the dots segments. And then we would look at this one. Again, we would say, is this a max or a min? Well, it reaches a minimum point here, so that's a minimum. The domain, I almost feel like we shouldn't even ask you what it is because it's the same every time, but it's a question they will ask. And then someone else I haven't heard from yet today, if I could hear the range. Range. Sam? Good. The smallest that it ever gets to is at -4. The largest is infinity. All right, we are going to skip the next one just because it's really similar to the ones that we've already done. But if anyone wants to see it, it is online on my note page. You would want to just make sure you rewrote that first, obviously, since it's not in standard form before you identify your A, B, and C. But I want to get to one that is actually a trinomial, not just a binomial. So we'll take a look at 4, and then I'm going to have you guys do 5 as a closure. All right, so this one actually has an A, a B, and a C. So A is 1/2, B is 1, and C is 3. So we'll find the vertex using our negative B over 2A. So that will be -1 over 2 times 1/2. And then you always want to multiply the numbers in the denominator first, because sometimes the fraction will go away. In this case, it does. 2 times 1/2 would be 2 over 2, which is just 1. And then -1 divided by 1 is just -1. Now be careful when you plug this back in without a calculator that you do follow your order of operations with your negatives. So this would be 1/2 times -1 squared plus 1 times -1 plus 3. And then following your order of operations, do your exponents first. -1 squared is a positive 1. 1 times 1/2 is 1/2. Positive 1 times a -1 is a -1. And then we have our plus 3. In order to subtract these, most of you would just take 1/2 minus 1, and we would get -1/2, but if not, make a common denominator. 1 minus 2 gets us a -1/2. You can switch that around to be 3 minus 1/2, which would be 2.5, which is probably easier. Otherwise, you can find a common denominator. Okay, so our vertex this time is falling on a decimal. That can happen. Axis of symmetry, again, is going to be x equals whatever the x value of the vertex is. So x equals -1. So let's go ahead and plot that. So -1, 2.5. And the axis of symmetry this time is this one. Now, if you remember from the front, you can find the y-intercept and reflect it. So the y-intercept, if we go back to our front page notes, it's always going to be 0, c, which is the constant value. So the y-intercept, you don't have to do any work for it. It would just be 0, 3. And again, that's just our y-intercept. You could also plug in 0 and you'll see that that happens. So 0, 3 goes right there. Now I'll reflect that about this axis. Now the problem is if you only have those 3 points, you don't know if it's going like this or if it's going like this, right? We don't know if it's real steep or if it's kind of stretched out. So I would find one additional point. This time we could pick +1. Actually, that's going to give me the same point. No, it's not. No, it's not. Or you could pick 2, because it has a denominator of 2. That way it would divide out and not have fractions. But it doesn't matter what number you pick as long as you pick something and plug it in. But 1 squared is 1 times 1/2. So 3 plus 1, 4, 4.5. So go to 1, 4.5, put a point. Then we'll reflect that across the axis of symmetry to get another point. And then that's probably enough to If you want to be on the safe side, you can always come up with more points. Now this one, also, when you're doing these, you can use your graphing calculator to A, graph it, and B, do the table of values for you. Do you remember doing that with the absolute values a little bit? So just to show you guys again, if you open up your graphing calculators, everyone get them out. Because you will get to use a calculator on your next quiz. We're not doing anything with the stat menu. We're doing stuff with the graphing buttons. So because this equation is y equals, you can press the y equals button. Obviously clear out whatever we had typed in there last. And you can type in the quadratic function you see. So 1/2, remember in your calculator, obviously most of you will put 0.5. But if you need to put a fraction in, you just put parentheses and division. So parentheses 1 divided by 2 is 1/2. The X button, especially Austin, I don't know how much you use this in Mr. Crowley's class, but the X button is right underneath the mode, xt theta n, and then we'll square that, then add x and add 3. 1/2 x squared plus x plus 3. And then a couple things you can do, obviously, is you can graph it or you can use the table feature. Some students like to use the table feature, so second graph, and then this will give you some points that you can either write down or just look at and then plot on your graph paper and then connect the lines. If you want to see a picture, you can press the graph button. Uh-oh, I still have my stat plots turned on. Let me turn those off. Okay, some of you might see this picture. Remember, when you press the graph button, it's zooming into wherever you had it set last time. So when you want to reset your graph, press the zoom button, and 6 is standard. Zoom 6 will always reset the window to be a -10 to 10, -10 to 10, which is what our graph paper usually looks like. Anyone not seeing this on their calculator? You also can find the vertex using this. So you might want to jot down this too. I'd like you to do it by hand, but I also like to use the graphing calculator. We will obviously graph the function, then you'll press second trace, and then you'll choose either option 3 or 4, which will say min or max. Okay, it doesn't actually have find the vertex, it just has find the min or max. So you'll have to look at the graph and think, obviously I have a min, this is my min value. So if you'd like to find it using the graphing calculator, you can choose, again, all I did from the graph was press second trace. This time I'm going to choose minimum, which is option 3. Now it will prompt you with a couple questions. It will say left bound. So you need to be to the left of the vertex. So left bound would be over here, right bound would be over here, and then it's going to ask you to guess. So all you have to do is take the cursor and just move it like somewhere to the left. It doesn't have to be anywhere specific, just as long as it's to the left of the vertex. Hit enter. Right bound, take your right cursor, move it over a couple times. Hit enter. You'll see these two little triangles that are like pointing and they should be facing each other. And then it'll ask you to guess. And you're going to get as close to the vertex as you can. Hit enter and it will calculate it for you. Now there is a little bit of error sometimes with the calculator. It should just be -1. There shouldn't be a 3 there, but you can see that it's basically what we found. Okay. So for this one we would say it's a min, obviously, domain -infinity to +infinity. And then our range this time would be what? Our range. What's the smallest the y value ever gets, and what's the largest? Jared?
Bracket 2.5, infinity.
Good. 2.5 up to infinity. All right, I want you guys to try 5. If you want to move around and work with a friend, you can. As soon as you're done with it,
I'm not taking the elevator right now.